In this presentation, we are going to see the following things: definition of embedded systems versus general purpose computing system, history of embedded systems, classification, major application areas, purpose of embedded systems, characteristics and quality attributes of embedded systems. These are all related to first unit in the embedded system design subject. Strictly speaking, embedded system definition according to Shibu KV textbook, an embedded system is an electronic electromechanical system designed to perform a specific function and is a combination of both hardware and firmware or software. You can see that some of the differences with respect to embedded system. In general purpose system, we can say that it is a system of combination of generic hardware and operating system for executing variety of applications. Whereas in the case of embedded system, it is a system of combination of special purpose hardware and embedded OS for executing specific set of applications. Again, one more difference, that is, contains a general purpose operating system. In the case of embedded system, it contains embedded OS only. Embedded OSs are specifically designed for embedded systems. These devices are different from general purpose computing system, like they are very small, compact. The design is not possible directly into the embedded systems. Somewhere we have to develop. After developing, generated executable file will be loaded into embedded device. Now, applications are alterable in the case of general purpose computing. In the case of embedded system, once the program is written or firmware is written in the memory, it cannot be alterable. Performance of a general purpose computing system depends on how fast the general purpose computing is working. That is the key deciding factor. Whereas in the case of embedded systems, application specific requirements like performance, power requirement, memory, all these are deciding factors. Now, for general purpose computing, reduced operating power requirements, options for different levels of power management are very less in number. Whereas here, highly tailored to make advantage of power saving modes. It is in the designer's hands how best the power can be reduced. Based on that, designs can be modified. Response requirements are not time critical. For certain category of embedded systems like mission critical systems, response time requirement is highly critical. Need not be the deterministic in execution behavior. If a particular operation is not performed because of some delay or because of some resource problem, in such case, the response is not deterministic, but the result over non-deterministic operation is not a trivial one. But in the case of execution behavior is deterministic, that is, if the execution is not performed, the entire system may go to catastrophic errors. It is hard real-time system. General purpose system is costlier compared to embedded system. It is cheaper. It is designed using a microprocessor as a main processor unit. In the case of embedded system, it is mostly designed using microcontroller as a main processing unit. It contains a large memory semiconductor memories like cache and RAM. It also contains secondary storage like hard disk. It uses semiconductor memories but does not require secondary memories like hard disk or CD. It sometimes uses flash memory also. It is designed to do multiple tasks as per requirement, but here it can cater to a particular predefined task. It requires a huge number of peripheral devices and their controllers. It is cheaper as it requires less number of peripherals. OS or other systems, other software systems are normally complicated and occupy more memory space, whereas in this case, RTOS and other software occupy less memory space. Now let us see history of embedded systems. The era of embedded systems started in the years of 1960, developed by Apollo Guidance System by Charles Stark Draper at MIT. After 5 years, Autonet is developed by D-17B, the computer used in the Minuteman missile guidance system. After 3 years, first embedded system for a vehicle was released, and the Texas Instruments developed for the first time with microcontroller 1971. 1987, first embedded OS, that is VxWorks, was released by Wind River. Microsoft Windows Embedded CE is developed in 1996. By the late 1990s, first embedded Linux system appeared. Embedded market reaches $140 billion in 2013. Analysts are projecting an embedded market larger than $40 billion by 2030. Now let us see the classification of embedded systems. The major classification is based on generation, on complexity and performance, deterministic behavior, and on triggering. When it comes to generation, these are categorized into 4 generations. First generation, like built around 8-bit microprocessor. Hardware also very simple. Firmware also simple, that is digital. Example is digital telephone keypads. And when second generation computers, they are built around 16-bit microprocessors, also 8-bit microcontrollers. There are more complex and powerful than 1 giga microprocessor microcontrollers. As an example, SCADA system. Third generation, built around 32-bit microprocessor, also 16-bit microcontrollers. And as an example, robotics, media, etc. Like concepts like digital signal processors, application-specific integrated circuits are solved. Fourth generation, built around 64-bit microprocessor, 32-bit microcontroller. The concepts of system on chip multi-core processors are evolved. Now, highly complex and very powerful examples are smartphones. Small scale embedded systems, these are all depends on like complexity. So small scale embedded systems, medium scale, large scale. So if the applications are very simple, build around low performance, low cost, 8 or 16 microprocessors, as an example, electronic toy. And medium scale embedded systems, slightly complex in hardware and firmware requirements, built around medium performance and low cost, 16 or 32-bit microprocessors. Usually contain operating system. And the last one, large scale embedded system. These are highly complex hardware firmware built around 32 or 64-bit disk microprocessor. Response time is critical. Examples mission critical applications. Now, classification is also on deterministic behavior. Based on the task execution behavior, whether it's embedded system design is meant for deterministic or non-deterministic can be known. Based on execution behavior, real-time embedded systems are divided into 2 types: hard real-time, soft real-time. And categorization is on triggering also. Reactive in nature can be based on triggering. Reactive systems are event triggered and time triggered. The major application areas are like daily life, electronic appliances, healthcare, education, communication, security system, entertainment, and also banking, automation, navigation, consumer electronics, household appliances, automotive industry, and healthcare, Now, what is the purpose of embedded systems? Majority of the embedded systems will be used in one of the applications: data collection, data communication, data processing, monitoring, control, application-specific user interface. Data collection is usually done for storage, analysis, manipulation, and transmission, whereas data can be analog or digital. As an example, here a digital camera is shown. It's a typical example for data collection. And images are captured, and the captured image may be stored within the memory of the camera. The captured image can also be presented to the user through a graphic LCD unit. Second one, data communication. These are deployed in applications from complex wireless communication to simple home networking systems. And data communication, wireless modules, Bluetooth, Wi-Fi, wireline modules, USB, TCP, IP, network hubs, routers, switches are examples of dedicated data transmission embedded systems. Data signal processing, embedded systems with signal processing functionalities are employed in applications demanding signal processing like speech coding, audio video codec, transmission, applications, etc. And this is an example of data signal processing, that is hearing machine. Digital hearing aid improves the hearing capacity of the hearing impaired person. Monitoring is another purpose, that is electrocardiogram machine, ECG or EEG, is intended to monitor the heartbeat of a patient. Digital CRO, digital multimeters, and logic analyzers are other examples. Control functionality contains both sensors and actuators, in which sensors are connected to the input port or capturing the changes in the environmental variables. Another example, air conditioning system. It takes the room temperature and sets the temperature to a specified limit in the AC by control. An application-specific user interface, that is buttons, switches, keypad, lights, bells, displays, units, etc. Application-specific user interfaces. Example, mobile phones. In mobile phone, the user interface is provided through the keypad, system speaker, vibration wires, etc. So these are all topics related to first unit. We'll catch up in the second unit.